Hello guys, I'm Guru Prasad and currently I'm studying in SVC Bengaluru and I'm from ISC department first year. Today I'm going to explain about triple integration and center of gravity. So let's begin the video. Let's move on to the integration. What do you mean by triple integration? The actual meaning or the volume by triple integration is defined by triple integrals are the types of multiple integrals that can be used to calculate the volume of three-dimensional region. The three-dimensional in the form of x, y, z regions like x-axis, y-axis, and z-axis in the three-dimensional manner. The general formula of triple integration is three intervals e of function of x, y, z, that is e of function of x, comma y, comma z, that is differentiation to the dv. Here E is the three-dimensional region of the integration, and f of x comma y comma z is the integrand, and which is function that we are integrating over. dv is the volume element, which is the three-dimensional differential. The volume of element can be expressed in a different coordinate system, such as Cartesian, cylindrical, or spherical coordinates. Let's move on to the center of gravity. Center of gravity of three-dimensional object is a point which the entire mass of object is evenly distributed. We all know that center of gravity is that mainly it is three-dimensional object which is equally distributed for the each three parts. So center of gravity can be calculated using the triple integrals. The formula is integral of x of rho of dv, integral of y of rho of dv, integral of z of rho of dv. Here rho is the density of the object, we all know that, and x comma y comma z are the coordinates of the center of the gravity. And next move on to the volume of the triple integration. Same thing, the volume of the triple integration is the defined as with the help of three Cartesian variables, that is x comma y comma z. For example, in the Cartesian coordinates, the volume of the element is dv is equal to dx, dy, dz. That are the differentiation. To calculate the volume of three-dimensional region using the triple integration, we need to follow these steps. First, choose the coordinate system, then define the three-dimensional region of the integration, then express the integrand in the terms of coordinate system, then evaluate the triple integration and we'll find the solution. And this is one example. Let's say we want to calculate the volume of the unit cube in the Cartesian coordinates. We all know that the unit cube is defined as the region where 0 is lesser than or equal to x lesser than or equal to 1. Same as 0 is lesser than or equal to y, that is lesser than or equal to 1. And same 0 lesser than or equal to z, and that is lesser than or equal to 1. The integrand is simply 1. Since we are integrating over the unit cube, we all know these conditions. The volume of element is dx, dy, dz. Therefore, the triple integration is the volume of unit cube is given by triple integration of 1 dx, because the integrand is 1. So 1 dx, dy, dz equal to 1. The integral can be evaluated directly and the final answer is to be 1. The final conclusion for this example is triple integrals can be used to calculate the volume of any three-dimensional region. The specific steps involved in calculating volume depends on the coordinating system which we are chosen. All depends on the coordinate system. Whatever we chosen, that is more important. However, the general formula of triple integral is always same, because we have to find the dx, dy, dz according to the x, y, z coordinates, that is Cartesian coordinates. So the choosing the coordinate system and defining that conditions is very important in this problem. So next move on to the one example. Let us discuss ds, dz, dy, dx three conditions. Then intervals are 0 to 2, 0 to 1, and 0 to x square minus y square plus z. Here now we are going to integrate with respect to first. We are going to integrate with respect to z. The z come back to the from the right side. First we'll get the 0 to x square minus y square plus z, that interval. So let's integrate with respect to z. That is, the integral will become x square minus y square plus z, the dy by dx or dy into dx. Then next we are going to integrate with respect to y. So x square, only x square will become x square y, minus y square will become y cube by 3, plus z is become zy. That is with respect to the integral of 0 and 1. Next move on to with respect to dx. So while applying the upper limit and lower limit, we'll get the x square minus 1 by 3 plus z to z dx. Next, with respect to dx, then this will become x cube by 3 minus 1 by 3. That is x is not there, so x. So while applying the 0 to 2, that is the integral limits. By applying the 0 and 2 upper limit and lower limit, we'll get the final answer as 6. This is the one example for the this question. Next, move on to the center of gravity. Center of gravity is an object, its point which has the entire mass object is evenly distributed. We all know that all the mass, entire total mass is distributed for the each part very perfect manner, because in x-axis, z-axis and y-axis we all the object mass is evenly distributed. There is no compromise in the distribution of the mass. So it is the point around which object will balance if it is suspended from any point. The center of gravity of an object is important in many applications such as designing such structures that are stable and safe. So the CG of object can be calculated using the formula. We all know that center of gravity equal to integral of x of rho of dv divided by integral of rho of dv. Center of gravity is the coordinates of the center of gravity. CG, that is defined as center of gravity. X is the x coordinate, rho is the density of the object, dv is the volume of the element. Next, we'll discuss about the center of gravity, how it works. Center of gravity of an object can be determined experimentally by balancing the object of the knife edge. The point which is the object balance is the center of gravity. The center of gravity of an object can be changed if the object is shape or mass distribution is changes. If it is mass is equally distributed, there is no change in that object. For any variation in the mass distribution, the center of gravity will change. For example, if a person bends over, the center of gravity moves forward. This why this is why it is important to keep your back straight when lifting heavy object. The center of gravity remains over your feet. The center of gravity of your object is also important in determining the stability of an object. An object is stable if its center of gravity is located below its base. If it is located below base, the center of gravity is stable. If the center of gravity is above the base, the object is unstable because the mass is not distributed even equally. So the center of gravity is fundamental concept in physics and engineering. It is used in many applications such as designing structures, machines, and vehicles. The center of gravity is also important in understanding the motion of object. Motion of understanding the concept of motion of object will plays a major role in the center of gravity. So this is the examples like standing, walking, and walker. Let's move on to the additional facts of the center of gravity. The center of gravity of a uniform object is located in its geometric center. The center of gravity of an object can be outside of an object itself. For example, the center of gravity of a donut is located in the hole. The center of gravity of an object can be changed if the object shape or mass distribution changes. The center of gravity of an object is important in determining the stability of the object. The center of gravity is a fundamental concept in the physics and the engineering field. So this is how the stability of the equilibrium and unstable equilibrium, how the torque is works. Next, model center of mass and center of gravity. There are some differences between the center of mass and center of gravity. The center of mass is a point inside the body which is the whole mass is supposed to be concentrated. A force applied at this point produces the translatory motion. By the way, center of gravity will a point inside the body to to which the weight of the body acts. Center of mass. Center of mass is the pertains of the mass of the body. Center of gravity refers to the weight acting on all particles of the body. Next, center of mass. Center of mass in the small body, center of mass and center of gravity coincides. In the center of gravity, in the case of huge body center of mass and center of gravity, it will not coincide. Next, move on to the center of mass. Center of mass is algebraic sum of moments masses about the center of mass is zero. Center of gravity is algebraic sum of moments of weight about center of gravity is zero. Center of mass is used to study translatory motion of the body when it is the complicated motion. Center of gravity is center of gravity is used to know the stability of the body where it is to be supported. We'll conclude that center of mass is mainly works under the translatory motion, and the center of gravity works under the all the weight which is present in the body acts. How the body acts, in that way the center of gravity works. Let's move on to the conclusion about this presentation. Triple integration of the center of gravity are powerful tools that can be used to solve the wide variety of problems in science and engineering. They are fundamental parts of calculus. They are essential for understanding the behavior of three-dimensional object. That is, the center of gravity plays a major role in the physics and engineering. It is a point of which is the entire mass of an object eventually distributed. Equally distributed mass is known as the center of gravity. It is a point around the object will balance if it is suspended from any point. The center of gravity of an object is important in many applications such as design structures and all the engineering and physics fields, because that all the engineering that center of gravity applications are all are stable and all are very safe. So the center of gravity will plays a major role under the translatory motion and all the like engineering, physics, and all the different sectors. So center of gravity is very important. So this is all about the center of gravity and the volume of the triple integration. I hope you guys enjoy this video. So please like, share, subscribe the video as much as possible. Please share. So kindly watch at least 3 to 4 minutes. Please. Thank you all.